All right, can everyone hear me? John, if you could just you're the only one I can see, so if you can give me a thumbs up. Okay, cool. Hi, everyone. So my name is Lizzy Glenzer. Your software. We are partnering with the Red Hat training team today. We're the ones who are sending you guys all of the messages and everything. So just going to give a short introduction to who Fierce Software is if you guys aren't aware already, and then we'll get started with the webinar. So like I said, we're Fierce Software. We're a value-added reseller and a public sector specialized partner, Red Hat. We sell all of Red Hat, but specifically today we're focusing on the training team. So like I said, value-added reseller. So we try to do a lot of events like these to enable the community and kind of make sure that you know what Red Hat is doing and getting the most out of your subscriptions if you are a current user. So Fierce Software is actually, this year we were awarded Red Hat's Advanced Training Partner of the Year. So we love working with this team, and we're happy to be doing this with you guys today. And, if you have any requests for stuff like this that you want to see, obviously let us know, and we, would be more than happy to do so. We work with Red Hat as well as several other, top tier open source vendors in the community. So we're happy to be here today, and John is going to be leading the event today because he is the smart one in the room. So I will let him talk. If you guys have any questions, we have the event chat on the side. Justin, John, and I will be monitoring that. So if you guys have any questions, feel free to put them in there. I'm sure John will try to answer any questions as he can, but I know that there's also going to be a Q&A section at the end. So he will definitely address things there as well. But I'm going to mute myself and let John get started, and we will send you guys a follow-up after the event. So thank you.
Awesome. Thanks, Lizzy. And so again, welcome everybody. I'm John Walter. I'm the solutions architect for the training team here in North America. Along with me as well as Justin McSheehy and Alex Unger. They are our partner managers. They can answer any questions as well. Today we're going to be talking about Kubernetes. This is our kind of Kubernetes 101 session. We'll be talking a little bit about containers, Kubernetes, and ultimately about OpenShift and why we're moving in the direction of containerized workloads. A quick look at the agenda. We're going to essentially start at that smallest unit of compute. We'll talk a little bit about what is container, why are we moving away from virtual machines and more towards containers to host our applications. Talk a little bit about why Linux is a really foundational technology for understanding containers. From there, we'll move into Kubernetes. That's container orchestration. What is the purpose of container orchestration? And then we'll move into OpenShift. Really an enterprise Kubernetes platform. After that, we'll talk a little bit about some of the training that we offer, available through Fierce Software. And then, as Lizzy said, we will have time at the end for Q&A. So if you have questions throughout, feel free to drop them into the Q&A portion, and we'll be able to answer those. If there's anything that Lizzy or Justin or Alex are able to answer in the during live session, they can do that via chat. Otherwise, we'll have time at the end to get into those. So with that, go ahead and get started. So what is a container? Hopefully, this isn't the first time that you're hearing about containers. If it is, then you certainly chose the right webinar. But and I'm going to use some kind of cheesy buzzwords a little bit today, and I apologize in advance for that. But we talk a lot about digital transformation, which I'll be honest with you, kind of always makes my eyes roll a little bit. But it is very much indicative of what we're trying to do here, right? Digital transformation is really about becoming a great software company, and it requires a lot of steps, right? And on the left side within this chart, you can see really what we've been doing for the last 10, 20, 30 years, right? We're trying to move away from a lot of these processes or ways of deploying our applications. We're trying to move away from waterfall development more towards continuous integration, continuous delivery. We're trying to move away from deploying to on-site data centers where we can, and moving more towards the public or private or hybrid multi-cloud. And the goals of these steps should really be to focus on the business outcomes. So that's increasing speed, agility, and control. And when we talk about those three things, we're talking speed as it means how can we implement new ideas more quickly? Agility meaning when it comes to things like updating our applications, can these changes be done more simply can they allow for greater experimentation? And then finally, for control, we're talking about how do we face risks in security and issues with bugs? How can we approach those more quickly and mitigate them from the start? And so, taking a look here, when you look at the development process, the deployment, the infrastructure, the architecture, and even the endpoints, we're really moving away from these giant monolithic applications more towards microservice architectures, which we'll talk a bit later on. We're moving away from on-site data centers and virtual machines more towards containers that are running in maybe AWS or Azure or on top of an OpenShift on top of OpenStack, or maybe a hybrid of all of the above, and that's really Red Hat's stance. And so it really all is about defining a new method for integration. We have to find a way, and we need a way for our applications and the way that we're approaching the design of those applications to be more agile. We need it to be scalable. We need to exist across those public and private, that hybrid multi-cloud, and really the open hybrid multi-cloud. And ultimately, we need to be able to iterate more quickly and more efficiently. And so on the left side, you have that traditional integration. It's not really compatible with cloud development, right? We have that enterprise service bus that's serving as that middleman between where we're deploying in the actual applications. But we need modern architectures to be more scalable. We need it to be more agile, and that's how we're going to enable things like the Internet of Things, or AI and machine learning, and these edge cases as well. And so that brings us into what are containers. And I think depending on who you're asking, if you're talking to your IT operations teams, the infrastructure teams, they're going to say exactly what a container is from a technical standpoint, right? It's a way of having an application sharing a kernel. It's a way of provisioning essentially a lightweight operating system that hosts that application, and you can start to divorce the application itself from the underlying OS and infrastructure. And that means that you can run it across all these different environments. You don't have to necessarily provision the same virtual machines for all these different containers, because you can run them across all kinds of different infrastructure. Now, for the actual developers, it's all about a method of delivery, right? It's being able to package the application with all the dependencies and the runtimes and not really have to worry about that underlying infrastructure. You're going to see a theme here that really containers takes away having to worry about the, not necessarily compatibility between the application, but you never really have to consider what runtimes the OS is running, because everything that application needs to run is actually packaged with that container. The other thing that you're going to see is that applications that are typically deployed in containers are going to have a much shorter shelf life. They're going to be typically bursting in a way that you aren't going to see cross deployments on virtual machines, and they should be more easily accessible and able to share across multiple teams, multiple organizations, and obviously across multiple infrastructures. So we're going to talk a little bit now about virtual machines, why we're moving away from VMs to containers, and hopefully this will make a little bit more sense. And I should preface this all by saying that there are always going to be needs for virtualized operating systems and running applications directly on VMs. And you're going to see more and more that virtualization is becoming more and more a part of our container platform, OpenShift. And so organizations, they've typically and traditionally co-located multiple applications on a single virtual machine. And that's typically due to operational overhead, resource costs of maintaining those virtual machines. And you can see here on the left side, while virtual machines are isolated from each other, the applications don't really have any kind of isolation, and potentially could negatively impact files on the OS, configurations, behavior, even the other applications themselves. Whereas on the right side, where you look at Linux containers, they share a container host, they share a kernel. These are very much Linux technologies, and at the same time, they're using those kernel technologies, things like control groups, SE Linux, namespaces, and all of that is to provide isolation so that one container can't access or impact the others, nor can it impact the host, the underlying host itself. Now, I will add a caveat that you can have those containers access each other if you want them to, right? Maybe you need a web server running in a container to access a database that's running in a nearby container. You can provide access to these, but it's all going to be defined by a rich set of rules. And so Linux containers in a way are sort of like virtualization technology, right? VMs are for virtualizing the hardware, while containers are for virtualizing the actual application processes, no matter where they're running, right? So when you take a look, that hardware, the hypervisor, the container host, it doesn't matter where it's running, right? It can be bare metal, it can be virtualized, it could be running on any numbers of private, public cloud. And so, while it's possible to run every app that you have on a single virtual machine, the overhead, the resource cost, it's typically going to invalidate any kind of benefits that you're going to get from that. So, VMs, they have the advantage of providing that hypervisor level isolation for the application, but that comes at the cost of having to run essentially a complete operating system for each application. That's going to consume more memory, more CPU, and the VMs, the compute, the memory, the capacity, it's all predefined, right? So you can't provide any kind of elasticity or bursting when an application runs more memory or computing power. And the containers, meanwhile, they're providing isolation through taking advantage of those kernel technologies we were talking about before. So things like C groups, like namespaces, like SELinux, which have been battle tested, and they're used for years at Google or the Department of Defense, and it's all there to provide application isolation. And so since containers use a shared kernel and container host, they reduce the amount of resources that are required for the container itself, and they're more lightweight than virtual machines. So containers are providing an unmatched agility that's really not feasible with VMs. For example, it takes a few seconds to spin up a containerized application, and containers, they support a more flexible model for when it comes to the compute and the memory allocation. It allows for, I mentioned before, like bursting. As you're getting higher traffic to that application, we're able to scale that container, which is much more lightweight than an operating system, in a way that we can't really do with standard virtual machines. And you'll see a big correlation between DevOps adoption and container adoption. This isn't really a coincidence, right? Containers have played a really important role in enabling organizations to implement DevOps without some of the obstacles that they faced in the past with virtual machines. And so when you talk about VMs as the unit of compute, applications are developed by the dev teams, the results delivered as some arbitrary package, usually varies between teams or maybe between applications, and that's delivered to the IT ops teams, who are responsible for building and deploying and managing the underlying infrastructure, typically a virtual machine. And they have to worry about the VM, the operating system, libraries, the dependencies the application needs, and then ultimately they are now responsible for the application itself. And so that kind of creates that conflicting atmosphere between your dev teams, your IT ops teams, any other teams that are involved in that delivery, because now the ops team is forced into ownership of an application that may not be documented, may not have standard layers within the technology stack. And they're not familiar with how it was developed. They're not familiar with the dependencies that it necessarily needs to run. They're having to rely on instructions from the dev teams, which may be fantastic or may be negligible. So that's on the VM side. When you look at containers as the unit of compute, there's really a clear boundary between the layers of the technology stack that the IT ops team has and the dev teams, and what they own and manage. And so your dev teams, they're going to be familiar with the application they build, the dependencies, the configurations, all of these things. And with containers, they're able to essentially own the application and its configuration and package that all together into what we call a container image. And so then they can hand this container image over to the IT ops team, and it's basically just this standardized package, right? We'll talk a little bit about OCI, standards, Open Container Initiative is OCI. And so, we're delivering essentially the same kind of package every single time from the dev team to the ops team. And now the ops team, they're just owning the infrastructure. They're owning the container host and the virtualization layer and all of these things. and they're running standardized images. And so they can deploy, they can monitor, they can manage these containers from these images across all kinds of infrastructure using standardized processes and procedures without having to adapt, their virtual machines, the underlying architecture every time a new application comes their way. And so by using containers, your dev and your ops teams, they can work at different speeds, they can upgrade and downgrade, the servers or the applications kind of independently of each other, and they can easily move applications between these different environments. And so there's a clear ownership boundary between the dev and the ops teams. They can work seamlessly during the application delivery cycles, and it really lays a ground for enabling successful DevOps adoption across the organization. So there's been efforts to standardize the virtual machine format. It's just never really succeeded. When you're using VMware, VMs on-premise are tied to vSphere, whereas if you're using a public cloud like AWS, they're tied to AWS hypervisors. And so, moving an application from, between infrastructures, it can typically require having to rebuild the application based on where it's actually, what the chosen infrastructure is, and then redoing all these verifications on the previous infrastructure. And so we're trying to move more towards, as an industry, immutable infrastructure, and we're trying to simplify deployments and management of the software and applications that are running on that infrastructure. And so, we worked with Netflix, actually, as an example, who they needed to make a change in production. They were having to bake that change into a new VM on AWS and then ship that VM to production. And we've now sort of helped them in their adoption of containers to take a really, really different approach, right? And when they started, Linux containers, the ecosystem wasn't really mature. And since it's matured, they've now moved away from, baking these VMs, having to build new VMs every time they want to make a change in production, to just building these containerized images. So finally, containers, they provide that application portability. There's that standardized image format. But portability doesn't necessarily mean compatibility. Portability is often believed to mean that you can take a container image, run it on any container host built on any Linux distribution. That's not 100% accurate. They're still, still have to be built for the right binaries. You can't have a 64-bit binary running on a 32-bit host. But for the most part, that compatibility and portability is pretty thorough. And so, making sure that you're running and you're building the application to run on the right infrastructure is important. It can lead to, if it's not compatible, it can run into like sporadic failures, complete failures where a container isn't going to run, and potentially lead to degradation, security issues, things like that. And so that's really where these standardized container images combined with a standardized container host, something like Red Hat Enterprise Linux, it will help you to enable that and provide that portability, that compatibility across the entire life cycle. And you may, if you've been to a conference where Red Hat's been a part of it in the last 3, 4, 5 years, you may have seen us walking around with these containers are Linux t-shirts. And that's because the containers themselves are essentially Linux containers, right? And the majority of containers that are out there are Linux containers. And so if you have a background in Linux, then you can start working with containers pretty much right away. You can really easily spin up some Docker containers and get, once you essentially run or execute the container, it's just a lightweight Linux OS. It's essentially a virtualized OS right there. And so it's going to have all the same technologies that you're used to from a Linux perspective. And you don't have to really reinvent the wheel. You don't have to necessarily learn a whole new paradigm. It's really going to build on your existing skill set if you're familiar on the Linux side. So to summarize, containers in a nutshell, containers are really changing the way we think about application architecture, the speed at which teams can deliver on those business requirements we were talking about before. And they promise that application portability across the hybrid cloud environments. They allow developers to really focus on building their applications instead of having to worry about the underlying infrastructure that's going to be deployed to or any kind of execution details. And while containers are removing the complexity through minimalism, managing containers and managing the deployments, it presents a new challenge for these IT operations teams. This is not the presentation does not end here, right? By introducing containers, we're solving problems, but we are also creating challenges, right? And so containers that are deployed for much shorter periods of time than a VM, there's typically going to be greater utilization of the underlying resources, and related container technologies that have to manage so many more objects with a lot more turnover. And so that introduces the need for automated policy-driven management. And so that's why teams are starting to move towards Kubernetes platforms. Kubernetes, it has this rich set of features that helps them to orchestrate and to manage the containers across their entire lifecycle environment. And so we're gonna jump into containers in just a second, but really Kubernetes, we're gonna jump into Kubernetes in a second, but really Kubernetes has emerged as the de facto standard for container orchestration, for container management, and it's really becoming a critical platform for organizations to understand. So what is Kubernetes? And this is, by the way, my favorite slide of any presentation I get to do. I just love every time I see this Michael Scott thing, it cracks me up. But we talked why containers are popular, right? They allow you to run the application wherever you want. It's an isolated process with its own resources. And because they allow the Linux kernel to manage the compute resources rather than performing the costly operation of virtualization. And so this lightweight nature means that each application gets its own container. It prevents dependency conflicts. So think of a container really as like a zip file. It's a tarball. And so containers, they're a way to bundle the code, the configuration, the dependencies, all in one go. And so the bundling eliminates the problem of, it worked in my environment, why didn't it work in your environment? And ideally, applications will produce the same output regardless of the environment, and the containerization makes it really ideal and easier to reach that goal. And so because applications are increasingly being built as discrete functional parts, we're going to talk about microservices in just a little bit. Each of these discrete functional parts can be delivered as its own container as opposed to these giant monolithic applications. And so that means for every application, there's now more parts to manage. And that also means that those containers are going to have a shorter lifespan than those traditional VMs that we were talking about before. And so, the complexity of managing applications with all these different objects, with greater churn, that's where these challenges come into play. And the challenges are really around configuration. How do I configure my cluster? And how do I configure the actual applications themselves? Service discovery, load balancing, resource scaling, discovering and fixing failures. All of these things, managing this complexity manually is pretty much impossible unless you're just running like one or two containers. Clusters, Kubernetes clusters typically going to be running thousands of containers. And updating these clusters is really infeasible without automation. And so that's where Kubernetes comes in. And Kubernetes, it delivers production-grade container orchestration because it is able to automate a lot of the container configuration. It's able to simplify scaling of the individual containers and pods themselves, and it's able to manage that resource allocation. And so essentially Kubernetes can run anywhere. You can have it across all those different cloud providers that we talked about before. And so whether you want your infrastructure to run in the data center that you have on site, you want it to run on AWS, you want it to run on OpenStack, or some kind of hybrid configuration of all of the above, Kubernetes is able to deliver this feature set at a massive scale. So Kubernetes in a nutshell. When we talk about more complex applications consisting of multiple components, containers vastly simplifies the updates. So place each component in its own container, make it simple to make changes to those individual components without having to worry about that cascading ripple effect like you would in a more traditional monolithic application. And so this simplicity has led to containers becoming a really great way to develop and deploy microservices. And microservices are essentially just applications with a single function. And they really benefit from containers because they provide a clean separation between the components and the services. And so Kubernetes, it's an open source container orchestration platform. It helps you to manage the distributed containerized applications at a scale, at an enterprise scale. And so you tell Kubernetes essentially where you want your software to run, and the platform pretty much takes care of everything else. And so Kubernetes, it provides a unified API, so you can deploy web applications, batch jobs, databases, all of the above. And applications in Kubernetes are packaged in containers, and they're cleanly decoupled from the environment like we talked about before. And so what Kubernetes is doing is automating the configuration of your applications, and then it maintains and tracks resource allocation. And so when we talk about container orchestration, this really means Kubernetes is figuring out where and how to run your containers. And more explicitly, it provides these three functions. So first, schedulers and scheduling. And so what this is doing is schedulers and scheduling intelligently compares the needs of the container with the health of your cluster. And it suggests where the new containers might fit, essentially. So think of a scheduler sort of as thermostat, right? You tell your thermostat you want it to be 70 degrees, and you expect the thermostat is going to maintain that temperature setting. So periodically the temperature or the thermostat is checking what you've set it to what the actual temperature is. It's doing that on a regular basis. And so in the same way, we're essentially telling Kubernetes, we want you to be checking on the health of the cluster and the health of the individual containers. And so I now, as a developer or as an operations person, no longer have to really worry about constantly checking the health of my cluster or the health of my application. Kubernetes is doing that for me. And so now if I'm a developer, I can just focus on building my apps, updating, adding new features. And if I'm the operations team, I can worry about putting fires out. From a service discovery and load balancing perspective, any system service discovery can be a challenge, and Kubernetes is not immune to that. And so the more services that make up an application, the more difficulty your application is, or I should say, the more difficult it becomes for your application to track and to manage. And so what Kubernetes has is it's able to automatically manage that service discovery for you. And so we might ask Kubernetes to run a service like a database or a RESTful API. And what Kubernetes does is it takes notes about these services, and it can return a list of a bunch of different statistics for me and information if I ask about it later on. And so it's also checking the health of the individual services. And so let's say Kubernetes detects a crash in one of my services. First, it's going to automatically attempt to restart that service. And then it will do some kind of basic checks, but then it'll also have some more subtle health checks, right? For example, perhaps maybe the application, the database application hasn't crashed, but it's just running more slowly. So Kubernetes can track this, and it can direct traffic to a backup, so think of failover if needed. It can restart the application if I need it to. And it also incorporates that load balancing. So modern services, they scale horizontally. And by running a bunch of duplicates of that service. And so the load balancer is a really, really key piece that distributes and coordinates traffic across all these different duplicates. And so we make it really easy to incorporate, custom load balancing solutions as well. Things like an HA proxy, a cloud-provided load balancer from like AWS or Azure if you're running and deploying into the cloud. Same thing for OpenStack. And so the third component, resource management. Every computer has a limited amount of resources, right? It has a limited amount of of CPU. It has a limited amount of memory. And so Kubernetes is intelligent enough to know, and you can essentially provide this information to it as well more explicitly. But let's say you have an application that transcodes video, right? That's going to be very CPU intensive. Or maybe you have an application that's parsing text, and that's going to be very memory intensive. And so we know that video transcoding application is going to probably run out of CPU first, whereas that text parsing application is going to run out of memory first. And so obviously running out of either of these is a non-starter, right? We can't do that. And so what Kubernetes does is implement this kind of proper resource management. And it's able to do that by leveraging scheduling, right? Intelligent scheduling. It's able to understand and schedule applications to appropriately use the resources like CPU, like memory, while also staying cautious about overutilization that can lead to instability. So benefits Kubernetes. Scalability, for one. Kubernetes is automatically able to scale your cluster based on your needs, right? If you're getting more traffic, let's say you are let's say you're Walmart.com, right? We've got Black Friday coming up here in the States. And so as we approach Black Friday, we can predict that, traffic is going to increase and significantly on the day after, or probably the day of Thanksgiving these days. And so, we have an idea of what load's going to look like, the closer we get to it, but there may be spikes here and there that I'm not predicting. And so Kubernetes is intelligent enough with an autoscaler that as we're getting hits and as traffic is increasing, I can automatically scale the cluster and I can automatically scale the pods, the individual applications themselves, and replicate the actual applications themselves if necessary. Portability, we touched on this already, but Kubernetes is capable of running anywhere, right? Run it on site in your own data center, run it on the public cloud. It runs in a hybrid, right? That's really, really where the future is in the hybrid cloud. And so with Kubernetes, and you'll see this with OpenShift as well, the same commands are run and used to interact with the cluster on any of those methods of deployment. Speaking of deployment, consistent deployments. Kubernetes deployments, they're consistent across the infrastructure, and that's why those commands are universal. And so containers, they really embody the concept of immutable infrastructure, and that's what we talked about a little bit earlier. And all the dependencies, the set of instructions that are required to run an application, they're bundled in that container. And so a lot of the times this is boiled down, and I think this is kind of a crass way of putting it, but the pets versus cattle argument, right? With your applications, your monolithic apps that are running on your virtual machines, those are your pets, right? They are maintained for long periods of time. You know all the ins and outs and all how finicky that virtual machine is, and maybe you've got to do a little bit extra work, and you become really, really familiar with that virtual machine. Whereas with cattle, or with containers, we don't care, about the individual container. I'm going to spin this container up, and it's going to last as long as it needs to, and then I'm going to burn it down. I don't care about that thing, right? So they're really designed like cattle. They're mass produced. They're identical. They set themselves up in the same way every single time, and because they're immutable, any kind of additional configuration changes are not allowed, right? They have to be pushed from the developer into an update to that container image. And so there's really no fear in kind of killing off a container, starting another one in its place. It's going to replicate and be exactly the same. The consistent experience means that developers can spend less time debugging, more time innovating. And then finally, separated and automated operations and development. So it's common for operations and development teams to be in contention. We talked about that a little bit earlier. Ops teams, they value stability. They are more conservative about change. Development teams, meanwhile, value innovation. They have they prize a high change velocity. And so Kubernetes kind of resolves that conflict, right? Because of the intelligence, the automation of Kubernetes, operations teams, they can feel confident in the stability of the system. Whereas containers, they are meant to save developers time. And so that empowers really rapid iteration cycles, things like CI/CD. So real quick, I do want to touch on this basic Kubernetes architecture. And so what you're seeing here is a very, very basic Kubernetes cluster. And so, this is what the most minimal cluster would look like. You're going to see, master and worker nodes together. They're going to run the applications and the services. And so on the left side, you have the control plane. This is roughly equivalent to the concept of a master node, and it's the brain of the cluster. This is where scheduling and service discovery, load balancing, the resource management capabilities we touched on earlier, all of that is provided by the control plane. And we're not going to get into all the nitty gritty of these different pieces. We touched on the scheduling, services, discovery, and load balancing pieces, but the API server lives within the control plane. This is the point of contact for any application or service. Any internal, external requests that go to the API server, the server determines if it's a valid request. It forwards the request if it is, if they have the right level of access. And then etcd also lives in the control plane. So if the control plane is the brain, etcd is where the memories are stored, right? That's the hippocampus. And so a Kubernetes server without etcd is like a brain that can't make memories. It's a fault-tolerant, inherently distributed key value store. It's a really critical component of Kubernetes, and it acts as the ultimate source of truth for the cluster, storing cluster state, and any configuration at the cluster level. Meanwhile, you have the worker nodes. Oh, sorry, was there a question?
Yeah, sorry, John, to interrupt really quick, but I think it's a good one from the audience here. They're asking, is it a good analogy to say that Kubernetes is to containers what vSphere is to virtual machines? And I think, relating containers, Kubernetes, and OpenShift into the VM world might kind of hit home with a lot of people.
Yeah, so I would say Kubernetes, and we're going to touch on this actually the next slide. Kubernetes is not a complete solution. vSphere is something that is built for the enterprise, whereas Kubernetes lacks certain features, and I'm going to touch on that in just a second. And so that is a pretty accurate comparison. I would probably say that containers is to OpenShift as VMs are to vSphere. I would think if you're familiar with like VirtualBox or something like that, that's not quite a virtualization hypervisor for the enterprise. That's more what Kubernetes is, and we're going to touch on exactly why that's the case in just a second. But Kubernetes has a rich set of features. It doesn't have everything, and on the next slide we'll talk about a lot of things that it doesn't have, which is going to kind of lead us into OpenShift. So really good question. That's going to tee us up for this next piece. But real quick on this slide, what I wanted to finish on the worker node side, worker node is essentially what's running the application of the service. There are a bunch of worker nodes on a cluster. Adding new nodes is how you scale the cluster. And within those individual nodes, you have a kubelet, and that's essentially a tiny application that lives on each node, and it communicates back with the control plane. So the kubelet is essentially, if the control plane is the brain, the kubelet is like an arm, right? The control plane sends the command, the kubelet is executing the action. And then also within there is a container runtime engine. And the container runtime is what complies with the standards that are managed by that Open Container Initiative, and it's what's running the containerized application. And so it's the conduit between the container itself and then the underlying Linux kernel. But as I mentioned before, Kubernetes is not a complete solution. Kubernetes offers portability, scalability, automated policy-driven management. It is not a complete solution. It doesn't include all the components that are needed to actually build and run and scale containers. It doesn't offer an operating system. It doesn't offer continuous integration, continuous delivery tooling, or application services. We haven't talked about storage once. There's a lot of work that needs to be done to set role-based access control, multi-tenancy, security. We know how to secure the actual container itself, but what about the platform? And so Kubernetes has all of these pluggable interfaces, and we'll show you what that looks like in just a second, that offers flexibility and choice for users. But look at all of these different things that we haven't talked about, right? Image management, metrics. How do I get really detailed metrics and logs on my individual containers? We haven't talked about routing and networking, patching. How do I update these? If you take a look at this slide, and I know Alex is laughing right now because this is my favorite slide to show. This is from the CNCF, that's the Cloud Native Computing Foundation. They're essentially the governing body that's home to Kubernetes. Kubernetes is actually their first project. This covers everything from an infrastructure standpoint through the application and developer services. I'm not sure that you can see my my cursor, but here on the left side with orchestration and management, that's Kubernetes. That's one piece of this. That's just the orchestration piece. What about the runtime? What about the database that it might need? What about CI/CD? What about API management? What about the infrastructure piece of this, right? And so this is a small version of the landscape. And so if you're trying to build your own container platform, Kubernetes is just one component of that. Kubernetes done right is hard. You can install Kubernetes, you can play around with it. It's not going to take you but probably 10 minutes to get it up and running. You get a very basic Kubernetes cluster going. But establishing Kubernetes as a platform for enterprise to run business critical application, it takes a whole lot more. You essentially, let's take one component, identity management, right? With Kubernetes, you're going to be providing access to a bunch of different internal systems to employees, partners, customers. You have to adhere to all the security rules that you have in place. If you want to integrate your identity management platform into OpenShift, You're going to need to know about LDAP. You're going to need to know about DEX, which is an open source identity system. You're going to need to know about Kubernetes and how to integrate LDAP into Kubernetes. That's one component, right? So you essentially may need to be hiring a whole staff just to integrate one piece for identity management into Kubernetes. And so that's really where OpenShift comes into play. So what is OpenShift? Think of OpenShift as an overlay, right? So no matter what architecture you're choosing for your applications, what programming language, OpenShift is a unified platform that's going to provide a single and consistent development model across the build, test, deploy, monitor, review lifecycle of the application. And so what OpenShift is an enterprise Kubernetes platform. So all of the things that we talked about that Kubernetes provides is still the underlying piece of OpenShift. But what we've done is essentially, if I go back to a couple slides ago, we've essentially worked with each of these pieces. We've identified one project on the upstream, so the open source version of that project, and we've hardened it and we've integrated it into a Kubernetes platform, and that's what OpenShift is. So there's automation, there's streaming and different frameworks that are built in so that developers can actually develop within the platform itself. API management with Rescale, all kinds of different integration pieces for your applications as well. All of this tool set on top of all of the features that Kubernetes provides. So let me jump back here. And so a couple of things I'll highlight here. Self-service infrastructure, right? Allowing developers to provision what they need on demand. They don't have to open up a ticket with their infrastructure team to spin up an environment so they can actually test their applications. We've talked about consistent environments before, right? Making sure that no matter where the application is running, that it's a consistent experience, because all of the dependencies, the runtimes, even the application runtimes are all built into that container, the application itself. Having built-in continuous delivery pipelines so that your teams, your development teams, can automate every step of the application delivery process, make sure it's executed on every change that's made to the code or to the configuration of the application. Built-in logging and metrics, right? Getting rapid feedback is an integral part and aspect of application development. And so OpenShift integrates monitoring and log management to provide an immediate metric back to the developers in order for them to be able to study how the application's behaving, whether they made changes, and to be able to fix issues as early as possible in the application lifecycle. So this is what that overlay ends up looking like, right? What you see here at the very bottom, whatever infrastructure, the enterprise-grade container OS, that's going to be RHEL or maybe RHEL Core OS. And above that, orchestration and storage, that's Kubernetes. That's the Kubernetes piece. Every other piece of this is what OpenShift is bringing to the table. So a service catalog, being able to monitor, capacity management, CI/CD, which we mentioned before, policy management, security analysis. And then on top of that, the actual application services on top of the platform to provide integration, to provide a data analysis, things like that for the actual application developers. And so, if you're not familiar with Red Hat, we're the open source company, right? And so our secret sauce is, our ability to turn, all of these different open source projects into production ready, stable, secure enterprise products that then we provide support for. And so all of these components are supported by Red Hat for the duration of that support lifecycle. And so ultimately, what we're talking about, OpenShift is a smarter Kubernetes platform, right? I said it before, you can be up and running with a Kubernetes cluster in probably about 15 minutes. And if you're just running a few containers, you probably have everything you need. But as soon as you start to look at this from an enterprise point of view, you need the metering, you need the monitoring at the cluster level, you need application developer services. You need to be able to update the platform and the underlying OS seamlessly with the click of a button. You need to be able to scale from maybe 10 containers to 10,000 containers automatically and know that the underlying infrastructure will be able to support that. And ultimately, we want to make sure that we're able to move towards this DevOps environment, right? This is really the key ingredients towards modern application platform, and it should be based on what allows you to transform your traditional applications to build cloud native applications, to experiment with things like analytics and machine learning and serverless applications. And the application platform has to provide a consistent way for both your dev and ops teams to collaborate across the whole deployment footprints, from edge to air-gapped environments to infrastructure you have in your own data center and to the public, private, hybrid, open cloud. So a couple other things that I wanted to touch on with OpenShift before we get into the training piece. Container security is a huge focus, and really we talk about container security and we talk about infrastructure security. I've touched on, on the infrastructure side, the same technologies that we're using, it's going to be RHEL and then OpenShift. And so, your Linux administrators and InfoSec teams are going to be able to secure the underlying OS, that infrastructure layer, and the platform. And then they'll have knowledge of how to actually secure the containers themselves, and then being able to have container registries that are protected as well. So only the people who need to have access to those applications can access them. Only the developers who need to be able to publish those container images to that registry are able to do it. And having all of that role-based access control in place is really key. And then automation, right? Being able to have automated policy-driven deployments across any kind of infrastructure. OpenShift is providing that necessary tooling, the process automation to enable all of the different teams, no matter who they are, to operate this enterprise Kubernetes platform efficiently and economically. Now, one thing that we introduced with OpenShift 4, which is the most recent major version of OpenShift, is a full stack automated install. Installation on OpenShift 3 could be a little tricky. Basically, you had to configure the infrastructure layer, then the OS, and then the platform on top of that, and you had to kind of keep them all in lockstep, but they all had to be managed separately. With OpenShift 4, we now have essentially a bundled deployment where you can automatically what we would call installer provision or automated policy-driven installation, or you can still do it the old way if you need to, and have it kind of decoupled from the OS. But what this allows you to do, the OpenShift 4 installer includes RHEL CoreOS, which is essentially a container tuned kind of variant of Red Hat Enterprise Linux. And so what the install does is it configures the underlying provider, then it spins up CoreOS on top of that, and then it deploys our OpenShift cluster and the cluster services on top of that. And so instead of configuring and managing 3 separate entities, you now have one full stack automated installation process. And as part of that automated policy-driven installation process, right, that leads into automated deployment hardening operations as well, what we call operators. And so this is really from initial conception of the cluster itself all the way through your day 2 and ongoing operations. We have built into the platform what we call Operator Hub. These are certified from Red Hat. They're certified from a lot of the other vendors. So, let's say you use NetApp for your storage. You want to integrate that into your OpenShift cluster. There's probably an operator that you can essentially check out. You'll input a few variable definitions, things like that, and then boom, you're able to essentially attach that NetApp storage to your OpenShift cluster really, really easily. That's what this looks like. This is the Operator Hub. So we launched this in conjunction with Amazon, with Microsoft, with Google, Google being the largest contributor to Kubernetes other than Red Hat. And so what this is you can see here, and I know it's a little bit tough, it may be a little bit small, but you can see, there's some AWS Cloud Broker, Couchbase Operator, what else do we have in here? Dynatrace for monitoring, right? So a lot of the tools that you're probably already using in production, you're able to integrate really seamlessly into OpenShift. And we've integrated the Operator Hub directly into OpenShift. And so your teams, you can see here, this is from the administrator view, you're able to essentially check out these operators and install them across the cluster, and then you gain the tools for upgrading them from a centralized point. And on top of that, you can implement, these are all objects, right? In the same way that a a container or a pod as an object, and you can control who has access to that object. You can do the same thing with these operators. So you can make sure, for the developer tools operators, only developers have access to them. But for the monitoring and logging and tracing, maybe you need to have a mix of operators or operations team and developers that have access to those specific operators. And I mentioned this self-service for developers. They have the ability to interact with operators in a self-service manner as well, just like any other Kubernetes object. And so here you can see, a developer's view of essentially that same view of the installed operators. So this is, you can see all the different capabilities that they're exposed to, and they have self-service access to manage each of these different components. And so, ultimately what we're trying to do is build an ecosystem where there's an IDE, for instance, built into OpenShift, and so and various runtimes that are available to you. So we want this to be an ecosystem where developers can feel comfortable working within our code-ready workspaces to build their applications, manage them directly within the OpenShift platform, and then from the click of a button, deploy that, push that into their pipeline, have it deployed into production just seamlessly. So I know we're approaching the top of the hour. I did want to take a few minutes to talk about training. We do offer, training across our entire product portfolio. Specifically, we'll talk about our OpenShift training. I wanted to set the stage a little bit, talk about how we train, the different ways and modalities that we offer. Obviously, with COVID, we're not doing in-person training for the most part right now, but we have been doing virtual instructor-led training for several years now. So we were able to really hit the ground running once we moved to completely virtual offering. We offer virtual training in a couple different ways. We have a public calendar where you can look and see what classes we're running, and you can individually join those courses if interested. We also offer this in a private capacity as well. So if you and your team are looking to get trained on a specific course or courses, work with our team at Fierce, and we can help you to schedule a private training that's instructor-led as well virtually. And we, with all of these courses, we provide a robust lab environment that you'll access via your web browser. It's a full, in the case of these OpenShift courses, a full OpenShift cluster that you'll get access to. Courses around administration, around development, all of the above, which we'll talk about in just a second. We also offer our courses available in a self-paced manner. So if you're interested in just an individual course, you can get access to a course and take that course self-paced for up to 90 days. We also have a learning subscription, which would provide you access to our entire course portfolio for the course of a year. So that's about 60 courses. If you're interested in taking more than one course, it's definitely the best bang for your buck. So, if you're interested, I highly encourage you to reach out to the team at Fierce to be able to take great care of you. And you can always work with us to determine exactly which course or courses are going to be the right fit. From a training curriculum perspective, I wanted to touch on, we have a lot of OpenShift curriculum. And you can see here, this is actually in a month or so going to be quite out of date because we're actually in development of several courses right now. But our DO 180 is essentially our most foundational OpenShift course that teaches you everything around, how to create and manage containers from a container level. If you're familiar with Docker, we use something called Podman, which is essentially the same, although it's a little more favored in the open source community. And so it walks you through everything from creating containerized services, managing those images, and then deploying them into OpenShift and troubleshooting that deployment. From there, it really diverges into 3 separate tracks. We have our administrator-focused track, which teaches you everything from configuring and managing the cluster to actually operationalizing it. So essentially, DO 280 or OpenShift Admin 1 course is around day 1 operations, and our Admin 2 course is around scaling and day 2 operations. On the development side, our OpenShift Development 1 course is around containerizing applications. We would call this brownfield development. This is more around taking your legacy applications and modernizing them to be containerized. It also gets into things like implementing a CI/CD pipeline, how do I implement health checks into my applications, things like that. And from there, it really dives into microservices, whether that be via Service Mesh, Quarkus, or some of the other runtimes like Vertex or Wildfly Swarm. And so big focus on the development side. And then finally, we do have a DevSecOps focus course that's really around how do we secure these containers? How do I create an enterprise registry to manage all these container images? And how do I manage and secure the actual OpenShift platform itself? We will, I think, be sending out these slides. Lizzy, maybe correct me if I'm wrong. And certainly, I just wanted to give you a little bit of insight. I won't spend too much time on this, on these couple of slides. This is really more informational, but really around some of our core introductory level courses that build on what we've learned today. And then finally, if you're just a developer, you don't really care about the nitty gritty under the hood, Kubernetes stuff. You just want to get started deploying applications into OpenShift. We do offer essentially what is an 8-hour, so over 2 days course called Introduction to OpenShift Application. This is our DO 101. What this teaches you is really everything around just deploying an application from the OpenShift web console. How do I monitor and troubleshoot and scale that application? Really, it's kind of the bare minimum that a standard developer would really probably be doing within the OpenShift platform. And this can kind of jump off into some of our microservices development curriculum as well. And then I did have a little bit of information around the Red Hat Learning subscription. Again, this is 24/7 access to our complete course catalog. It also provides access to our instructors. So if you're looking for something a little more self-paced, but want to have that fallback so you can speak to our instructors as well, our standard Red Hat Learning subscription does provide access to our instructors as well. And again, emphasis on a lab environment. No matter how you take our courses, there is a lab environment provided for you across all of these different modalities. And then finally, we do offer certifications as part of this as well. We've just, in the last 3 or 4 months, rolled out remote certifications where you can take certifications from the comfort of your own home. These are proctored certifications, and so there's plenty of information that you can find on the Fierce site or at redhat.com/training. But the ability to take the courses and then take the certification exam from the comfort and safety of your own home is really key, paramount to validating your skill set. So I know that we're coming up at the top of the hour. I did want to make sure that we had time for any more questions. Let's see. I see a couple questions in here. Where does Docker run come into this picture? I might have missed that talk. So we use Podman as our container to build containers. Docker and Podman are essentially the same underlying technology. So think of Docker to run localized containerized applications. You're running them directly on the OS. OpenShift kind of removes the need for Docker run or Docker Swarm or anything like that. OpenShift, essentially, you would build the application or the container with something like Docker, but what most organizations do is leverage the CI/CD pipeline to take an application, maybe binary or from source or from a Docker file, and create a container image from that. So Docker is certainly a part of this, but it is not necessarily in a mature, I would say in a mature enterprise OpenShift deployment, Docker is typically not coming into play. Can we start with Kubernetes and migrate to OpenShift? Yes. Well, yes and no, right? So a lot of the the scripting, a lot of the commands that you use at the Kubernetes level definitely maps. So with Kubernetes, you use kubectl. That's the command line interface. All of those commands map to OpenShift's command line interface, which is OC. And so you definitely have, there's definitely overlap. I would hesitate to say that you can migrate directly from a Kubernetes cluster to an OpenShift cluster. I think there's not a seamless way of doing that, but certainly a lot of the resources, those individual components are the same. And so I'm not sure if it's a heavy lift or not. And then I see that Lizzy also dropped in the chat a link to the free trial for the Red Hat Learning subscription. That's definitely a valuable resource. But with that, Lizzy, I'll kick it over to you. I don't see any other questions in the chat that we didn't cover within the session. I didn't know if you wanted to say anything before we wrap up.
No, I am going to send out a follow-up email to everyone. I'm sure we'll be able to share the recording as well as the slides from the event. So if anybody missed anything or wanted to share with a colleague, just let me know. I'll also include the free trial link in the email as well. But yeah, if you guys have any questions that you didn't get to share here, feel free to respond to my email, and I'll, be happy to loop in John and answer any questions that we couldn't today. But thank you very much, John, and thank you everybody for attending. And like I said, if you have any questions, just feel free to respond to my follow-up email.
Awesome. And thank you all again.